Hello friends, I welcome you all to my channel. This video is part of the playlist Python Basics Programming Beginner's Daily Dose, where I try to upload videos on basics of Python programming so that beginner level programmers, Python developers, the programmers will get an insight how Python works behind the scenes for some very widely used concepts. in the This is part 3 of the series of videos on iterators and iterables. If you have not watched the previous part 1 and part 2, I highly recommend that you watch them first and then continue to watch this video. In part 2, I implemented a binary search tree and also implemented the iterable protocol where to implement the iteration of the values of the binary search tree in order, pre-order and post-order fashion. In this video, I will continue in this part 3, I will continue on iterators and iterables. I will address how to implement iterators using generators, which is a convenient way to implement iterators in Python. I will try to re-implement the binary search tree iterable protocol using the concept of generators. Before I get started, I will highly request all of you who are watching my videos and you are being benefited from my videos. You are learning something on Python basics programming. Please support me by subscribing to my channel and like my videos, share them with your friends, and also do not forget to press the bell icon so that you will be notified by my future videos, as I will be uploading these kind of videos regularly on Python basics programming. So let's get started with this video. Okay, in the previous part 2, I was implementing binary search tree class. I was implementing the iterable protocol, which is method, which is underscore underscore iter, so that the values of the binary search tree can be iterated in order fashion. The default iteration is to iterate the BST values in order fashion. Also, I wrote two other custom functions, pre-order and post-order, that will return iterator to iterate the values of the BST in post-order and pre-order fashion. Now, the way this iterator was implemented, I took a temporary list and was adding the values in this list for the corresponding traversal order, and from this list I was returning the iterator using the iter method. So another convenient way of implementing iterator in Python is to use generators. So let me first discuss what are generators. So generators, what are generators? Generators, the two basic concepts of generators are generator function, uh, generator function, and the second is generator iterator. Now, what is a generator function? Uh, a normal function, that has a yield statement. A normal function, okay, looks like a normal function, that has a yield statement, but but uh, but uh, its execution is completely different from normal function. Now, what is a generator iterator? An iterator, that is returned by a call to a generator function. Now I should mention here that uh, a call to a generator function returns a generator iterator. Iterator. So let's try to understand this with an example. Let's try to implement a generator function. A generator function is okay. I will take a very simple example. Let's say we want to now there are two kinds of generators, two kinds of in fact iterators, a finite iterators and an infinite iterators. Finite iterators are if you iterate, you will have a finite collection of items. If you do iteration on a finite iterator, you will get a finite collection of items. On the other hand, if you iterate on infinite iterators, you will get infinite number of items during while doing iteration. So I will consider uh, infinite. Let's say I will consider okay. I will consider a finite iterator. Let's say I define the function like this: gen odds. Let's say start val and how many. So now this function I want to implement. I want to implement a generator function, generator function, which will basically return all the odd integers starting from start val, and it will generate how many number of odd integers starting from start val. So what we do is uh, so odd. mm, So the basic logic will be that we will first check whether a start val is an odd or not. If it is an odd number, then we will definitely return that first, and then we will every next odd numbers will be we have to increment the value by 2. So the first odd will be uh, uh, if start val is an odd, then odd equals start val, else odd is start val plus. So if the given starting value is already an odd number, then definitely the first odd will be start val. If it is an even number, then mm, it will be 1. The first odd will be uh, 1. So we have identified the first odd number. Now we have to fetch how many numbers of odd numbers. So what we do is we will let's say we keep an index variable starting from 0 and while less than how many, because we have already found the first odd number which is odd, we will have to find another how many minus 1 number of odd numbers. So okay, now first what we do is we return the odd. How do we return? We actually not return, we generate the first odd value. We do that by saying with yield statement, yield odd. Now, so the next odd will be definitely plus 2. So if the current odd number is n, then definitely the next odd will be n plus 2. So and we increment the index variable, the count variable rather. Let's say this as count will be a better name, and we do count. So okay, so So we are yielding odd, and then we are changing the odd to the next odd number, and we are incrementing the count. Okay. Now, so this is a very simple version of the generator function. Because the function, any function, if there is an yield statement, that function will automatically be regarded as a generator function. Now, now let me first comment all the previous code output. Let me first explain the generator. Okay, so now we have this generator odds, right? Now, when we invoke this generator odd, when we invoke this generator odd, let's say with the starting value of, let's say, 4, and we want to generate 10 odd numbers, what does this function return? What does this generator function will return? It will return a iterator. It will return an iterator, basically, which is an iterator is a data object which implements the iterator protocol, that is next and underscore iter. And this this kind of iterator is known as generator iterator, because this iterator has been created or generated by a generator function. This gen odds is a generator function, and since we are invoking using that generator function, just see this to what, let's check what is the type when we invoke gen odds, what is the type of that data, or what object, whatever it is returning. If we run this, oh sorry, we have to do print and class generator. So see, the type of the gen odds, whatever it is returning, it is of type a generator. Great. So generator. So basically, it's an iterator. It's a generator iterator. It's a kind of iterator, but since it has been generated by a generator function, it is known as generator iterator. Okay. Let's save. Let's call invoke gen odds with 4 and 10, and so we will get an iterator. Let's save it in an instance or in a variable it. Now it is an iterator, which means if we iterate over it, we should get the values 5, 7, 9, 5, 7 and 9. Now how do we get those values? Since it is an iterator, we can call next on it to get all the items one by one. So if I do next it, it should print 5. Oh sorry, I have to print 5. Okay. If I do another call of next it, it should return 5, 7. Okay. If I do another, it should return 5, 7, 9. Okay. At this point of time, if I do another next, I should not get 11, because the way we are implementing the function gen odds is that I want 10 number of odds. Okay, fine. So yeah, it will return 11. Yes. So I can call this next 10 times 10 times. Okay, why I'm doing this? Essentially, gen odds should generate an iterator which when iterated should give odd values starting from 5 and 10 odd values, odd numbers, odd integers rather. So if I do make this next statement 10 times, I should see 10 odd. Now, for the how many odds I got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there must be some implementation mistake because it showed stop iteration because the last next when I'm calling the next when I'm invoking the last next on IT, before that the iterator has already been all the elements of the iterator has already been consumed. So this is not this is flaw of my code. So let me check genodes while count is 0, while count less than, I think it should be how many, little mistake in logic. And now I should get, yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got 10 odd numbers starting from 5. Okay. So this is the basic concept that I will use to implement now the iterator of the BST. So I will comment this, let the function remain. Now, so what we have to do is, so this is underscore underscore iter underscore underscore is the default iterator method that will iterate the BST values in order fashion. Now, so here I am recursively calling in order. I'm recursively calling in order fine, and that in order is actually returning something. This in okay, it is actually taking the list and it is appending the values. So we don't need the list anymore. Let me first change the underscore underscore iter method. We don't list need the list, and we don't this list to pass. We will use yield statement, and of course we also don't need this. We don't need to return because now this iter method, we are calling the recursive method underscore underscore in order, and in order in the in order we will use the if statement. So what we are doing is so this is in order, so it will first process the left subtree, fine. Left subtree, okay, we don't need the list anymore to pass around, and then it is processing the value of the node. Over here we will just do an yield, so generate the first generate the next item, that is the value of the node, fine. This should do okay, iter self, okay. Let's see if the default underscore underscore iter works or not. So we created this BS tree, let me uncomment that. And now iterate to print BST order, this thing. Let's uncomment this thing. This, so when we are using foreign statement with the BS tree, then it will use the default iterable protocol method of BS tree, which is the underscore underscore iter underscore underscore. This thing now should print 1, 3, 4, 5, 6. Let's check. No, type error. Iter method, iter returned non-iterator of type non-type for x in BS3. Why? But okay, so the protocol okay, so the protocol underscore underscore iter underscore underscore, it has a definite syntax. It must return an uh, iterator. Uh, it must return an iterator. but uh, since we are not returning any iterator, I thought this yield would work. What perhaps we have to do is we have to uh, this inorder underscore inorder is actually um, the generator function which is having yield. Now when we when we invoke this when we in iterator, okay, when we invoke this we will get iterator. When we are invoking this underscore underscore in order because you call this is the generator function because we are using yield. So when we invoke this, it will return a generator iterator. So we are storing the generator iterator in this, and we will just return a we can return this it. I hope this will work. Let's check. Okay, so BS3 in order is 5. Why only 1? Uh, mm, Not 0. Mm, it seems like the recursion is causing problem. It seems like a generator function cannot be recursive. The recursion is causing problem. I'm not sure about this. So let's get rid of the recursion in implementing the uh, iterator. So what I will do is I will get rid of the recursion. I will directly use here. I will use an iterator version of the in-order traversal. So node node will start from root, okay, and node will start from root. um, for iterative version of recursion, what we do is so we have to in-order traversal is uh, mm, okay, so how do we implement the iterative version of the recursive in-order traversal? Node, we start with the root, and okay, we start with the root. So if while node is not none, we should not process an empty node. So while node is not none, what we do is we first have to in order. So we first have to uh, process the left subtree. Process the left subtree while mm, left subtree. Mm, while node is not none. Uh, mm, 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 mm. Okay, what do we do? What in order traversal? Um, we left subtree, then node, then right subtree. So uh, Mm, we have to traverse the tree in order fashion and in the correct order. When we are reaching a node, we have to yield the value of the node. That is the basic concept. Uh, no, it's not none. This, mm, this, this. Hmm, I'm stuck here. I was not really expecting that the recursive call will cause problem in a generator function. Uh, I will quickly check whether uh, Python uh, generator function with recursion. Can generators be recursive? Can generators be recursive? I never tried to create a recursive generator, didn't work. This is what I get. Recursive generator is recursive generator is one. Uh, you're not yielding when you call it again. It hits the first yield, doesn't see another yield statement, and exits. Mm, you either need to yield from another generator or yield each element one by one explicitly in while loop. Recursive generator for k. I should point out this doesn't work because of bug in the function. Yield from. I should point out this doesn't work because of a bug in your function. It should probably include a check that ls and plus one below. If ls yield ls0 yield from recursive and don't have yield from. In case yield from, okay, recursive generator ls yield from. For yield from, let me try if yield from works or not. Yield from, okay. I just where is my in-order? I removed it. Where is in-order? Oh, yield from. Mm, why your code didn't do the job? In your code, the generator function returns yields the first value of the list. Then it creates a new iterator object calling the same generator function, passing a slice of the list and then stops. Mm, recursive generator some list. Your length is following. For example, yield from. Yield from visit tree. Recursive generator is useful for traversing nonlinear structures. For example, let a binary tree be either none or tuple or value. Left sub right tree. A recursive generator is the easiest way to visit all nodes. Example. Okay. So visit tree. If tree is not none. If tree is not none. Okay. Uh, try value tree. Okay. Except value error. Wrong number to unpack. Okay. Then yield from visit left. Okay, we have to use yield from. The basic idea is to use yield with recursion. We have to use yield from. Okay, let's try it out. Uh, so let's undo. I can the in order in order. Where is in order? Do we have in order? Insert helper. No. Yeah. Okay. Okay. We don't need this thing. We don't need the list. And in the iter we are calling this in order we calling the recursive method, which will be the actually the generator method. So in order, we don't, instead of this we uh, instead of this mm, uh, we do yield uh, yield node, the value, which is the first element of the node. Node here is a list of three items. The first item is the value of the node. The left, the second item is also a list, which is refers to the left subtree, and the third element is again a list, which refers to the right subtree. So yield. Now here we have to use yield from. So here we have to yield from. So if now I run the code bs3, what do we get? No, for x, bs3 is not defined. What is it? Oh, this thing, and if I run the code, iter returned non-iterator of type non-type. Okay, so in bs3, somehow this underscore underscore iter, this is Python is complaining that this is not actually returning an iterator. So what we can do is if we are invoking this, it will return an iterator. Let's save that in it. Let's return now it. Let's run it now. Okay. So now we got 1, 3, 4, 5, 6, which is fine. Now let's implement these two methods, post order, pre order, using the same concept. So for post order helper and pre order helper, we won't need this list anymore, and this will be yield from, since we are making a recursive call, this will be yield from, again a recursive call, and this will be just yield this. Okay, and post order, this is actually the method which will be invoked by the external from external program. This method will actually return an iterator to iterate the values of the BST in post order. So we don't need this thing, and we don't need this thing, and so this will be a generator iterator, and we return the iterator. Similarly, we don't need this thing. This will be iterator. We just return the iterator. We have to change the pre-order underscore pre-order helper. We don't need this thing. Please refer to my previous video part 2 to understand how I implemented the BS tree using where I implemented iteration protocol using a list. Then only you will understand this code. So I don't need this thing. This will be yield from and yield. So this concept I was not aware of, that if you are implementing a generator function and if that generator function is recursive, then then you have to use yield from with the recursive call inside the function. This will be yield. Okay, let's quickly check and see if the other also works or not. So the pre-order is printing 53146. 53146 is fine. 14365. Okay, it's working correctly. So you have so I discussed what are generator functions, what is a generator iterator. When you a generator function is a function, looks like a normal function but with an yield statement inside the function. And when you invoke a generator function, it returns a generator iterator, which is essentially an iterator, a kind of iterator. An iterator in Python implements the two protocol methods underscore underscore next underscore underscore and underscore underscore iter underscore underscore. And you also there's a built-in function next, which you can invoke on an iterator to get the next element from the iterator. So the two concepts are generator function and generator iterator. A generator iterator is returned when you invoke a generator function. So in the implementation of the default iteration of the base tree, we have a helper function, which is basically the generator function. This self underscore underscore in order. This function is a generator function where we are traversing the binary search tree recursively in order fashion, and when we have to process the value of a node, we are yielding the value of the node, and when we are making recursive call, we are making use of yield from. Similarly, the other two helper methods is same, just the order of traversal is different. So I hope this video gave you a little insight of how to implement iterators using generator functions. So the generators, the concept of generators basically has two things: a generator function and a generator iterator. If you like this video, then please support me by subscribing to my channel, and like this video, share it with your friends, and also please do not forget to press the bell icon so that you will be notified by my future videos, as I will be uploading these kind of videos on regular basis. Thanks for watching, and until the next video, take care and bye.